The first page are basically asking the same thing, but they're asking it two different ways, okay? They're asking about discontinuities. For a rational function, by rational, numerator over denominator. Really, the only problem you're going to run into is my denominator 0. Had this been a square root, you could run into another problem, imaginary numbers, right? So when they ask for discontinuities, they're literally talking about in the real number world, okay? So for these, they have told you exactly what they want you to test. So you need to test these 2 points and figure out if these specific points cause a problem. If it does not cause a problem, it is continuous at that specific point. If it does cause a problem, you need to figure out what type of problem it causes, okay? So for something like this, the first thing I'm going to do is probably factor it, because I can very quickly see if a problem is caused if I factor that denominator. And if we were able to factor the numerator, we would want to do that as well, because the numerator is going to assist me, even though the numerator is not what causes the problems, okay? So for this one, my numerator is not factorable. It is already in simplest terms. I am going to put this little negative right here. Don't forget him, just in case you need to use him. Technically, he looks like that. And then I'm going to factor my denominator. It's going to factor to what? What are my 2 factors? Yeah, -3 and +1. All right? And so now that I've done this, I'm going to look at these 2 points. And I'm going to say, okay, first I'm going to look at x equals -1. Does -1 cause a problem? Yes, it does. If I plug in -1, I get a 0 on the bottom. That is definitely a problem. So now I have to decide what type of problem. Can I cancel out what causes the problem with -1? Yes, I could cancel that x plus 1 on top and that x plus 1 on bottom. So you can see that the -1 can be canceled out and my problem could go away. When you can cancel it out, it is point discontinuity, okay? So when you can cancel your problem, it is point discontinuity. So I would say this is point. Point discontinuity at -1. And then I'm going to look at the next one. X equals 3. Does x equal 3 cause a problem? Yes, if I plug in a 3, I also get a 0 on the bottom. The difference is there is nothing for this problem to cancel with. So if I cannot cancel out my problem, it is infinite discontinuity. All right? Listen to me very carefully. If it did not cause a problem, you would put the word continuous right there. Because if it doesn't cause a problem, that function at that specific point is continuous. All right? If you have a function that is like a piecewise function for this type, you're probably going to be checking to see if it's a jump discontinuity. All right? So if it's discontinuous at that point for a piecewise function, it's going to be jump. It's going to jump over and start a new piece, okay? But for something like this, just a rational, it's either going to be point or infinite, or it's going to be continuous. When they hand you the points, it could even be continuous at that point, all right? It doesn't necessarily mean that it's one of those. So the second set of problems looks very much the same, except that it is not giving you points. It is saying, are there any discontinuities? You have to find them, and then you have to tell me what type they are, okay? So I didn't pull number 5, but number 5 is a piecewise. For this guy, you would just plug in the -5 to the top, plug in the -5 to the bottom. If they are a different answer, it is a jump, okay? If they are the same answer, it is continuous, all right? For something like this, you're going to do exactly what you did before. You are going to factor the denominator. You're going to see if anything causes a problem. If it does cause a problem, you're going to list it out, and then you're going to describe what type of problem it causes. So I'm going to do the same exact thing here. I'm going to factor the top if I could, but it does not. The bottom factors to x plus 3, x minus 1. Do any numbers cause a problem is my first question here. And the answer is yes. X equals -3 is a problem, and x equals +1 is a problem. Okay? And I'm going to do the same thing. Do either one of those problems cancel? They don't. Both of those are infinite. They don't cancel. So I'm going to write the word infinite beside it. This is an infinite discontinuity. This is also an infinite discontinuity. For page 2, you need that parent function guy, and you need to have memorized what those parent functions look like, okay? And so what you're going to do here is you're going to say, what parent function do I have? What picture does my parent function look like? And now I'm going to adjust my parent function based on all the information they've given me, okay? So when I look at this one, I see absolute value. Okay, that should give me a picture of a parent function, all right? So when I think of absolute value, I should think of a V. Specifically a 1 slope, right? A 1 and a -1 slope, right? For a V, a perfect V. And now I'm going to decide what happens to this V. Normally the V would start right here at 0, 0. But I have some movement in here, all right? The first thing I notice is this +3. That's going to move me left 3 units. Then I notice this +1. That's going to move it up 1 unit. Okay? And so I know where my vertex is. My vertex is going to be at -3, +1. All right? Now, normally this guy would open up at a 1 slope. This particular one has a negative in front, which means it's going to open down. Had it been a -2, it would have been a 2 slope. I would have gone over 1 and up 2, or down 2 in this particular case, okay? Had it been a 1/2, I would have gone over 2 and up 1, right? I would have gone up 1 over 2. So a 1/2 is going to flatten them out. A 2 would stretch them up, okay? By that slope. You can just go over 1 and figure out what it looks like. In this case, my slope is still 1, but it's pointing down. So this particular guy is going to go down 1 over 1. He's going to look like this. And so when you sketch him, he should look like this. All right, so when I see this, so we're flipping the other way. Last time we saw the function, we had to get a picture of it in our head. Here we have get the picture, and we didn't know what the function is. So this is a parabola. This should immediately make you think x squared. So I still need to identify my parent function. My parent function here is x squared. So I know this is going to be an x squared. Typically, my x squared would start right here at my 0, 0, okay? But in this case, I have moved. It did not flip, so I know I'm going to have a positive in front, all right? I actually know that it doesn't have a number in front. The way I know that is here's my vertex, and I go over 1, up 1, over 1, up 1. So I actually know that there's no number in front of my parentheses. What I do notice, however, is that my vertex moved, all right? My vertex moved over 1, 2, 3, and down 1. So my vertex moved left 3 and down 1. So I have something inside my parentheses and outside my parentheses, all right? Inside my parentheses, left 3 is going to be plus or minus 3. Plus. Yeah, it's opposite. You need that x squared right there. On the outside, I moved down 1. What does that look like? Minus 1. And that is my function. Notice your instructions here. It says identify the parent function. So in your answer here, you're going to see that y equals x cubed or y equals x squared as part of your answer, right? So you're going to actually have 2 answers. Yeah, so follow your instructions. Here you're going to have the parent function that's not moved, and then you're going to have how it actually changed. All right? And this actually helps you, by the way, because you get credit for recognizing the parent function, even if you were to mess up the movement. Does that make sense? Book, we actually talked about piecewise functions first and then parent functions, but I actually flipped it on your quiz because I feel like progressively that makes more sense to me. If you've already talked about all these different functions and then how to graph them and how to recognize them, now you're just putting together pieces of those parent functions, okay? So that's why I put it in this order. Basically what you want to do here is you have 3 different functions in this particular case, and you want to try to recognize the types of functions that you have, all right? So if I were to look at this guy, I would say, well, this top one, that's y equals mx plus b. That's a linear function. All right. This second guy right here, well, he's just y equals a number, which is a constant function. That looks like a horizontal line. All right. And then this third guy, they were nice. He is also a linear function. And so this one's not too bad. I mean, you could have a parabola, you could have an absolute value, you could have any type of function here. You need to recognize those parent functions that each one represents, okay? Now you have to keep in mind that this function has specific limitations for each one. So for the first one, it says less than or equal to -4. So in my brain, I'm going to do this little, okay, I need to do something to tell me I stop right here at -4. He's not actually part of my graph. I'm just like putting him there for the fun of it to help me know what I'm doing. So you could even do, if you wanted to do like a dashed line or something there, you could. But something to indicate that you're only going to this -4 for that first piece, okay? I'll tell you why I do that. Because when I'm graphing a linear function, I need to know where to start and where to stop when it's a piecewise function. If it were regular linear, it'd go on infinitely and it wouldn't matter. But in this case, it matters. So when I have that end point, -4, I'm actually going to plug in the -4 and see what my y value is at -4. Now, because it's or equal to, I'm going to put a closed circle wherever that happens. If it had not been or equal to, if it had just been less than, I would have still plugged it in and put an open circle wherever my answer happened, okay? So for this guy, I'm going to plug in a -4. So I have x plus 1. So I'm going to plug in a -4. And that's going to give me -3. So because it's inclusive, and by inclusive, I mean it is or equal to, then I am going to put a point at -4, -3, a closed point at that. So I'm going to go to -4, -3, and I'm going to put a point there. All right. Now, let's say you don't, it's a positive slope, all right? But I'm not going to the right. Am I? No, that's the end of this line. So I need to think on the left side, what does it look like? All right. If you can't get a picture, pick another point. All right. So let's say you can't figure out what happens here, but you know it's a line. Pick another point, -6. All right. Plug in a -6. -6 plus 1 is -5. So -6, -5 is going to be down here. All right. If you can't figure it out. Now, the slope is 1, so just go down 1 over 1. But let's say you don't do that. Pick another point that's in that less than 4, and you're going to know what happens to your line. This one's going down 1 over 1, so he's going to look like this. All right? The next piece of it, my constant one. For my constant one, which is anything that is between -4 and 2, inclusive on the 2, not inclusive on the -4, my function looks like this. Y equals -5. -5 is a constant function. Anytime y equals a number, it's just a horizontal line. No matter what x is, y is -5. All right? And so at that endpoint here, at this -4, my answer is -5, but it does not include -5. How do I indicate that it does not include -5? An open circle. At +2, my answer is also -5, but it is inclusive of that +2. So this is just a constant function. This is a horizontal constant. Remember increasing, decreasing constant? This is constant. It doesn't move. So this from here, this whole range that they gave me is just a horizontal line. Okay? We're just doing it piece by piece. All right, the last piece is also a linear function. This thing is when x is greater than 2. It is y equals 2x minus 4. All right? Now, even though it doesn't include 2, I am going to plug a 2 in. All right? So I'm going to say, well, what happens at 2? All right? So I plug a 2 in. 2 times 2 is 4. 4 minus 4 is 0. So at the point 2, 0, I'm actually going to have an open circle because it doesn't have an or equal to, but I do know that's where it begins, right here. Open circle at 2, 0. Now I can just do my slope, right? My slope is 2, up 2 over 1, up 2 over 1 here, okay? Now let's say you don't remember how to graph a linear equation. You can pick another point, pick a 3. Anything bigger than 2 is going to be part of this graph. Throw a 3 in there. 6 minus 4 is 2, right? So at the point 3, you should be at 2, 3, 2. So if you don't remember, just pick a point that is in that. And that is your piecewise function. There's two types. There's standard form, there's vertex form. I only pulled a standard form, but vertex form's, I think, easier somewhat than standard. All right, I am always going to ask you for these things: axis of symmetry, vertex, y-intercept, okay? It does not necessarily mean, and I think all of these actually fall, doesn't mean that the y-intercept is going to fall on the graph, but I still want you to tell me what it is, okay? Does everybody hear that? So your y-intercept could fall off the graph. You still need to sketch it appropriately. And you can always do that by moving over 1 and paying attention to your A, and use that as a slope for your first movement away. Okay, so you have to remember these shortcuts for standard form. Your axis for standard form is negative b over 2a. Your vertex for standard form is going to be negative b over 2a. That's your x value, and f of whatever you plug it in, negative b over 2a. That is your y value, f of x, right? And then your y-intercept is always going to be 0c. This is standard form. All right. Very quickly, even though it's not on this example, vertex form, your axis is just x equals h. And remember, it's the opposite of what it looks like. So you can write negative h if you want to. Your vertex, oh, did I say vertex? Yeah, that's vertex form, sorry. Your vertex is negative hk. And your y-intercept, you have to plug in a 0. So plug it in 0, and then whatever happens when you plug in 0 is your y value. So this is vertex form. All right? So you really need to know those to be able to do this guy. So let's look at the first one. My axis then. My axis for this guy is negative b, so negative 8, over 2 times a, which is negative 2. So I have positive 8 over negative 4. What is my axis? Negative 2. All right, so that is my first answer here. I am then going to go to negative 2 on my graph, and I'm going to do a dashed line. I need to see all of this stuff graphed, other than possibly your y-intercept if he's not on the graph. All right, so that is my axis of symmetry. My vertex then, well, my vertex is going to be what happens, so my x value is negative 2, I just figured that out. And then I'm going to plug it in, negative 2 times negative 2 squared minus 8 times negative 2 minus 4. So negative 2 squared is 4 times negative 2 is negative 8. Negative 8 and negative 2 is 16 minus 4. So my vertex is going to be 2, positive 4, negative 2, positive 4. Right? And so that is the second piece of this, my vertex. And I'm going to go to negative 2, positive 4, and I'm going to plot that point. All right? Going to plot that point. All right? Y-intercept. My y-intercept is just going to be 0 and c. So I'm going to go to 0c, which is 0, negative 4, and I'm going to plot this. Now, if your y-intercept falls on the graph, to figure out how to sketch this, just mirror him. So what I mean by that is he's here, he's 2 away from my axis, go 2 away from your axis on the other side. That is a mirror. And it's going to look like this. All right, but let's say he fell off the graph. You can look at your slope, so to speak, okay? That tells you how it changes, at least in the first one. The second one's going to be exponentially, right? But for the first digit away here, I should be 2 down. First away, I should be 2 down. I know it's down because it's a negative. And so even if your y-intercept falls off, you can go 1 away and then use your slope. Okay, and if it's a fraction, you can go your denominator away and down 1. okay, or up 1. And then once you have that, you can just sketch him, all right? This is a sketch. It's not going to be perfect. Really, I only have 2 ways that you are required to solve them, factoring and quadratic. And actually, I think for the test, I don't even force you to do it one way or the other. All right, they both have to be equal to 0 in order to do either one of these processes, okay? So you'll notice that the first guy is not equal to 0. My first step here then is to make it equal to 0 by moving that 5 over. I'm going to get 3n squared minus 11n minus 4. All right. You can do your rainbow method. 3 times 4 is 12. Factors of 12 that add up to 11. And then you can factor it out by grouping, right? Or you can just say, well, I need a negative 12 and a positive 1 here pretty much. So if you don't remember how to factor, you may want to remember that before too long. All right. I want a negative 12, so that means a negative 4 has to be over here. 3 times negative 4 is negative 12. Plus 1 would give me a negative 11, right? So I can just like pair them up when I have a prime. If I don't remember that, I'm going to do it over here for all my people who panic on factoring. Remember, you can do across. 3 times negative 4 is negative 12. Factors of negative 12 that add up to 11, that's negative 12 and positive 1. Rewrite it. 3n squared minus 12n plus 1n minus 4. Factor by grouping. Group here, take out my factor, 3n, n minus 4. When you don't have a factor, it's a 1, n minus 4. And then it factors into this guy, n minus 4, and 3n plus 1, which is what I got when I paired them up. All right. So if you don't remember factoring, you probably want to refresh that memory there. All right. Once it's factored, it's really easy going from here. What do I do once it's factored? Set each one equal to 0. 3n plus 1 equals 0. That's going to give me n equals negative 1/3. And then n minus 4 equals 0. That's going to give me n equals 4. So my solving x is going to equal either negative 1/3 or positive 4 at this point. All right. So quadratic formula is that x is going to always equal negative b plus or minus the square root of b squared minus 4ac all over 2a. Once again, this guy has to be equal to what to even do this process? 0. He is not equal to 0, so I'm going to move all this over. So I'm going to say 8x squared, add the 8x over, subtract the 13 over. Now it's equal to 0. All right? All right? Once I do that, I can just plug in my a, b's, and c's. So I have negative b, so that is 8. So negative 8 plus or minus the square root of 8 squared minus 4 times a, which is 8, times c, which is negative 13, all over 2 times a, which is 8. Then you're just doing order of operations, legit, okay? Order of operations. Negative 8 plus or minus the square root of 64 minus, what is it, 32 is 320 plus 90 is 410 plus 6 is 460. Yeah. Is it 416? Okay. Distribute. All right. Negative 8 plus or minus the square root of, add your 416 and your 64, which is what, 480? All over 16. Do not cancel just the 8 and the 16, please. That is wrong. We need to simplify my radical. All right. And then we need to pull out your simplified radical and go from there. All right. So if you don't remember how to simplify a radical, just do your factor tree. Normally I would do all primes, but it's such a big number, I'm going to start with something that's a little bit. Then I'm going to do primes from here, by the way. And then remember, if it pairs up, it comes out. So we have this pair, we have this pair. None of those pair, so you're going to have a 2 and a 2. So you're going to have negative 8 plus or minus 4. You have 2, 5, and 3 that stays in. Square root of 30. That's getting really tiny over here. I'm going to put it up here. Negative 8 plus or minus 4 came out. 30 stayed in. 16 on the bottom. Two ways to do this. If it comes out of everything, you can reduce it out of everything, or you can split it up into fractions. So I think your answer key just pulled it out of everything. 8, 4, and 16 have what in common? 4. Divide everything by 4. 8 divided by 4 is 2. 4 divided by 4 is 1. 16 divided by 4 is 4. So in your answer key, it's negative 2 plus or minus the square root of 30 all over 4. I will also take it if you split it up. Negative 8 over 16, negative 1/2 plus or minus square root of 30 over 4. So I'll take it both ways. If you want to split it as two different fractions and reduce, or if you just want to reduce out of everything, as long as you reduce correctly.